Welcome back to the channel, everybody. Today's video is going to be a long one, but don't worry. Down below, I'm going to have chapters for you. So, we're going to be rebuilding the slab saw today. Now, it's been a while since I've bought it, and I got a very good deal on this slab saw. It's a 14-inch slab saw that appears to be homemade probably in the 60s, which that was absolutely a thing back then. There wasn't a whole lot of lapidary saw manufacturers. People built their own equipment. So this thing's been kind of neglected for the whole time, it would seem. And, I bought this and I just started using it with all of the intention in the world of doing a rebuild. So what you're looking at right now is that saw that I'm talking about. Well, I had some problems with it, and it became time now to do this full rebuild. So I've kind of been slowly acquiring all of the parts, and I'm going to walk you through my rebuild on this and why I'm doing what I'm doing. And, if you are in the market for, an older slab saw for whatever reason, you might come away with maybe a different perspective on it. Maybe you're going to think that's not worth it or it is worth it. It's really up to you. But the reality is, a functioning 14-inch slab saw can run anywhere from $500 to $1,000 used, because a new 14-inch saw can be easily $2,500. So if you're thinking you're going to save a lot of time and money getting an old saw, you might, but these are like used cars, right? They're not all going to be created equal. And who here in this audience has had a cruddy used car experience? I think a lot of people have. So the way you can make this work is to get something old and used and be able to work on it yourself. And I'm going to kind of show you some of the things that I've done on my rebuild. So let's look at some of these parts here. So all saws basically work on the same kind of principle of you have a motor with a belt that goes up to a pulley. That pulley has an arbor, which spins in some bearings, and you have a blade that spins. And this is what the blade was that I was using. And, maybe you can see here, we got a bent blade. Flip it over. There you go. You can kind of see that thing rocking. That is not what you want. A number of things were happening with my saw that caused the rebuild. The bent blade, the vise was all wiggly, the pulley spun on the arbor, and it was a whole mess. And now, okay, so this thing's trash, right? And blades are not cheap. But we will be having a brand new blade. Let's talk about some of the other parts here. Kind of give you a little bit of an idea. So, new pillow block bearings. If you've never seen a pillow block bearing before, it's a bearing that spins in this housing. These are greasable, and we have the double set screw. So, I'm going to have that guy like that. This is an arbor. This will get threaded through that. And this is where the saw will be, the blade will be mounted. That pulley is going to spin here, and we have a belt that's going to be spinning this whole thing. We got new belts. We got a new flange. So this is going to be mounted up here just like that. And that's what's going to be pinching the blade between these two. This will get mounted on this arbor, and this will be just kind of loose and on there. This shaft is a keyed shaft. I had to cut these threads myself, and this is a whole thing that we're going to be talking about, because I really thought that the arbor was going to be one of the easier things to acquire, and it's not, depending on your saw. Now, if you're trying to do a rebuild on a more modern saw, you might be able to contact a manufacturer and just get, buy replacement parts. In my case, that's not really an option. Thankfully, These are kind of your standard automotive belts, V-belts, and I got all my parts locally, and you can kind of see we're kind of doing some major upgrades here with this as well. As an example, here's this dinky, like zinc casted pulley, which was the old one, and now we're doing a heavy cast iron pulley. So kind of across the board, we're doing all upgrades on everything. Here is my old arbor, and you can see what they did here is they took a 3/4 inch cold rolled steel shaft and they brazed onto this right there the end cut of a bolt. So they cut the bolt off and just brazed it onto this rod, and I don't want to do that. And here, where the pulley was spinning on there, it actually mushroomed it up, and it was quite the pain to get off. And this whole thing is shot now. So when it comes to cutting threads, right? So I used to have a lathe. I actually sold my lathe. A lathe being the easiest way to cut threads. So that leaves the next best thing, which is to cut them yourself. Now, this is a 3/4 16 fine thread. This is going to be the nut that I'm using, and this guy spins on here perfectly, just like that. And this is what we're going to be tightening that flange down. Let's talk about tapping real quick. Now, maybe you have a set like this yourself. You have these guys here. These are for chasing threads. Now, that would be like you have a bolt and the threads are all messed up. You can send these down it. And you can see in here that will kind of reopen those threads. This will not work for making your arbor. You're going to have to use one of these round ones, which are adjustable. And we'll be talking about this and the tap guide system, which you're definitely going to have if you're going to be building your own arbor. So if you want to cut threads that are like a 1/2 inch rod or bigger, you're definitely going to need a vise to be able to put your stock in and clamp that thing down. You're going to need a tap handle, and you're going to need the appropriate die, which the die is this little middle piece here, and it gets clamped in here with the screws. These are adjustable. There's a little spreader screw in there, and you can adjust this, because now, you know, the threads that you cut have to be a little bit smaller than the nut. They can't be exactly the same. You know, if you've ever put a nut on and it's like too tight or too loose and it's got that jiggle, or you just can't put it on, the threads were either too big or too little. So since we're going to be cutting them, that's what's happening there. You can adjust this down a little bit. They usually come from whoever you bought them from, adjusted and ready to go, but you might have to tighten that down just a hair, you know, like that 1/4 turn on that. Okay, so this is modified with a guide on here. So the way this functions is I'm using this, right, to be able to keep my tap handle straight. I'm going to show you what happens now on the whiteboard if you do not have a guided system like this. And this is something, all the aluminum here, this is what I built myself. And this is something that you would really need a drill press to make with any type of accuracy. I'll put a video link down below on how you can make one, but it's pretty much a necessity if you're going to be using a tap handle and you're not, I guess, not a pro. So I think this will give a good representation as to why you need a guide on your tap handle. So you have your threaded rod. Now, if you start your handle spinning on that rod at a little bit of an angle, that angle is just going to get worse and worse as you get farther down the rod, and your threads are going to get lopsided. And as you get farther and farther down, the ones on one side will get shallower and the other ones will get deeper. And in turn, the nut right, isn't going to sit square. It's going to sit like that. Now, the goal of the nut is to press up against your flange right there. So you're only going to have a little bit of contact, and things are going to be wibbly wobbly, and it's going to suck. So, going with the guide to keep you straight on track, you will get straight threads cut on your shaft, just like that, and it will be awesome, and you can look at it and be like, stoked, right? You also need to use some thread cutting fluid. I like everything Tap Magic makes. It's also like they got the happiest. There we go. Not sponsored by them, but come on, look at that happy little tap. Adorable. Okay, all of these auto feed saws essentially have a vise running on a track, and it pushes your rock that's clamped in that vise into the blade. You need to make sure that your blade and your vise are flawlessly parallel, okay? Otherwise, because if it's like, cockeyed in or out, like pigeon-toed or whatever, you're going to have pinching on the blade as it tries to move in and pull away or push in or whatever. They got to be perfectly parallel. This is how you figure that out. So I've had this thing for a long time now. This is a cheap micrometer with a magnet base. I'll be showing you how to kind of use this thing. You don't need a fancy one for this. We're aligning a saw blade. We're not, we're not doing fine machining here. So made in China is okay, I guess. But anyways, so you can see we're going to have this thing set up, and we can see even the tiniest little movement here, right? To get that perfectly straight. So you're going to have to buy one of these. Here is the current state of my saw. It's empty, mostly clean. You can see the vise, which is kind of disassembled on the rails. Those are the mounting points for the pillow block bearings. That arbor runs through there, and we're running down to our motor. Obviously, you can tell that I'm not doing a full restoration on the saw. This is good enough for me for now, which I think that's going to be the case for most people. You don't buy a used car and do a full restoration on it. Well, I mean, I guess some people do, but I'm not. I just need this thing to be up, running, and cutting. So, here it is kind of mocked up so that you can kind of see we have the blade there, pillow block bearings, except, well, there's a problem. Here is the old pillow block. And now you can see that these ones, my replacements, are a little bit higher. So the casting foot is thicker. So here's the problem with that. This is how this would typically go with that blade, the vise, except now you can see we're kind of hovering there and hitting here. So I need to open up this hole, but then that's going to let oil kind of spurts out. So we got some thinking and adjusting to do. I will probably just cut this opening a little bit bigger to allow for the thicker, modern pillow blocks. But we should be able to line this up just right. Well, here I am mostly aligned. I'll show you the alignment process here real quick, but you can see how this is all set up now. These bolts are kind of firm. I can still move the whole assembly around by giving it little tippy taps with the plastic dead blow. I do have nylock nuts on the back of this. Now, if you don't know what that is this. That is a nylock nut, and that's just a nut with a nylon insert that kind of helps hold it firm. I used a deeper ones than this. This is a little shallow guy. So my reason for the nylock is, well, it's more secure ultimately, and it allows you to progressively tighten up your bolts. And I'll show you the alignment here on how I did that and why I think that's necessary. So you can see how I have this set up. It does not have to be perfect. You can see that just the littlest movement here moves the gauge. And as I push my vise, you can see we have some run out. So that dropped down like, oh, you know, see the thing is too, I got this play in my vise, but for what I'm doing here, that is perfectly good. I personally find a little bit of a run out to be acceptable. So I didn't start with this, but I just kind of wanted to show it to you set up. I initially did some eyeballing of this to try to align it like that, and I'll show you what I used for that now. So kind of as the first phase of alignment for this blade, which is kind of a fiddly process, I used a trim square. And I set it up here, and I just slid the vise back and forth and tried to eyeball that gap and kind of just drag it across the blade so it was uniform, so that I could then snug this down a little bit, get the gauge, run the gauge on it, and get it as aligned as I think it's going to be. Now I can really, really, really wrench on these and get it super, super tight, come back and check it again. Well, I've done some off-camera progress. It's been a couple of days of fiddling around and waiting for stuff, but I got the lid back on. You know, I did some more assembly of the little aluminum guards. We got some foam in here. We need to talk about the vise and the speed in which this runs. So this saw is different than some other ones, that we have our motor running our blade, and we have an independent motor down here which would turn this shaft, which would send the vise down the track. This little motor, right, this little guy, turns at 6 RPM with a 2-inch pulley on it. Now, before I had a 4-inch pulley up here. So before, I had this 4-inch pulley, this one right here. It's a double, but I never used this. So let's talk about the speeds that I was getting out of this. This vise was moving at 15 inches per hour of infeed. Now, for some things, that might be okay, right? Like your softer materials, things like that. Harder materials, I feel like it was too fast. Now, what is the right speed? Higher end saws, you have multiple speeds that you can select from. I just have this pulley. So I did a little survey of people I know that have saws, and a lot of them, they were between 10 and 12 inches per hour of rock feeding into the blade. Covington Engineering has a little chart up, and they say that 8 inches per hour is slow, 24 is fast. Well, unless I'm changing out my pulleys, I'm not going to be able to really adjust it. So we have this little motor. We have this little motor down here, which is turning at 6 RPM with a 2-inch pulley. Going up to a 4 is 15 inches per hour, which means I want to reduce it down 20%. If I run a 5-inch pulley here, that will reduce the number of RPM 20%, which should get me at my 12 inches per hour cut speed. So I have, we're walking, I have a new 5-inch pulley here. You may have saw that the shaft that this is turning on has no flat spot for the set screw. So I will grind a flat spot on that threaded rod and be able to have the set screw in there and it'll lock it in. I'm going to opt for trying one of these guys. So your typical V-belt looks like this, right? It's your black rubber V-belt. I'm going to try one of these. Now, I've never tried one of these before, but if there's ever a time for trying something, it's, well, first off, it's on your own machine. And second, it's on something low speed that you can keep an eye on. And, well, 6 RPM is pretty slow speed. So I can definitely keep an eye on it. And who knows, this might be good because I have extra. So if I wanted to do a 4.5-inch pulley or a 5.5-inch pulley and slow it down even more, I can. Some examples of that would be this type of really soft material here. This is garnet with ambolite. Very soft material, right? I could probably cut this a lot faster than I could this big piece of petrified wood. So that's kind of my thoughts on possibly running different pulleys in the future. So I'm going to grind on that. I'm not going to let you watch me do that. That's annoying. And then we'll get this guy hooked up. All set up. I just ran a test with this, and I got a little under 13 inches per minute. So slower than what I had at 15 before. Not exactly 12, but I'm going to try this and see how it goes. I could always get like a 5 1/4 inch pulley, or like a 5 1/2, and do that in the future if I feel like I need to. The belt seems good. I mean, we'll see how it goes. So anytime you have a non-keyed shaft like this, it's good to put a little mark, and then you can see if your set screw came loose and you're spinning on your shaft even just a little bit. I mean, I put Loctite on everything, so we should be good, but you never know. So really all that's left at this point is to add some oil, and then we'll set it up and we'll do a test cut. Oh, it's so quiet compared to what it used to be. Hasn't started cutting yet. It's just now making contact with that rock. You can barely hear it starting to chip into it. So much quieter. Moment of truth here. Let's see how it did. Sure enough, that's cut. I'll get this cleaned up here. Let's get this open. And that surface on the bottom there, that was cut with the old blade and everything. And well, we have our new surface, and we'll be able to compare and contrast the surface finishes. Well, here is that rock that I cut, and this is that finish on it. I think it's pretty good. You can feel a little bit of ridging, just very, very slightly. I would say that this was slightly smoother. I mean, very marginal. But oh my gosh, the saw was significantly quieter. It really makes me wonder if the problem before was those old bearings, and now I have bearings that I can grease, and they should last a long time. And very happy with the cut. I think it's good. This is a piece of rhyolite, by the way. Well, I think it's a project that anybody can tackle. I hope you found this video to be helpful to you if you're going to be tackling your own slab saw rebuild. And, I'll catch you on the next one, everybody. Thanks for coming by and watching.